In order to resize a photo, I'm going to want to keep the photo similar to the original. So if I look at my first three choices, A, B, and C, photo A has been resized. And if you compare photo A to the original, this photo, the person in the photo is too skinny. And if you look at photo B, this person, after it's been resized, looks too fat. But if you look at that third photo, the way that the third photo has been resized, that photo is just right. So the photo that's similar to the original is C. If you look at numbers, if the original photo is 5 by 7, 3 by 5, 5 by 5, or 2.5 by 5.5. Well, in order to get to 3 by 5, I would subtract 2 and subtract 2. To get to B, I'd keep my 5 inches the same, but subtract 2 from 7. And to get to C, I would take both of these numbers, 5 and 7, and divide by 2. So the one that's similar to the original is actually C. And if I look at these photos, my original photo was actually 5 by 7. A, 3 by 5. B, 5 by 5. It's a square. And C would be my 2.5 by 3.5. So the dimensions that keep similarity, C. The operations that keep similarity are the ones that keep proportionality. And to keep proportionality, we need to divide and multiply. When I add or subtract, I don't keep proportionality. When I subtract 2 and I subtract 2, losing 2 from 5 is a bigger percentage than losing 2 from 7. That's why A looks too skinny. B, when I keep my 5, my first dimension the same, and I change my second, that's when I get a photo that's too fat. It's only C that keeps proportionality. So how do I define two polygons as similar? Well, the first thing that has to happen is the angles have to be congruent between those two polygons. And the second thing that has to happen is the side lengths have to be proportional. And there's a symbol that we're going to use for similarity. It's the congruent symbol without the equal sign. It's just that squiggly line over the equal sign. This symbol means similar. Let's look at some examples. Are the following polygons similar to each other? Well, number 1, are the angles congruent? Well, in this case, congruent, 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 congruent. Yes, the angles are congruent. The second step, I need to make sure that my sides are proportional. Well, if my opposite angles are congruent in these shapes, then these shapes have to be parallelograms. And in parallelograms, opposite sides will be congruent. So I actually know all 4 lengths. So to check proportionality, I need to set up a proportion. I'm going to start with 4, and I'm going to compare it to 7. And then I'm going to switch to 6, and I'm going to compare it to 9. So I've gone from 4 to 7 and then from 6 to 9, and I need to check this proportion. To check this proportion, I'm going to cross multiply. 4 times 9 is 36. 7 times 6 is 42. 36 does not equal 42. So these sides are not proportional. So even though I have my angles being congruent, my sides are not proportional. So no, these shapes are not similar. If I look at my original photos, I was dealing with all rectangles. And in rectangles, all my angles are 90 degrees. So yes, my angles were all congruent in the first pictures. It was just the sides that I needed to check proportionality. Let's look at this last example. The following isosceles trapezoids are similar. Well, that tells me a lot. Isosceles trapezoids have one pair of parallel sides. That's what trapezoid means. Isosceles trapezoids also have one pair of sides congruent, just like isosceles triangles. And since I know that they're similar, I know that my angles are congruent. So if my angles are congruent, I know a whole lot. If this angle is 70 degrees, it's going to be congruent to this angle, 70 degrees. And in an isosceles trapezoid, my base angles are going to be congruent to each other. So if this angle is 70, this angle is 70, which means that this angle is 70. And since I have parallel lines, my consecutive interior angles will be supplementary. But I have an isosceles trapezoid, so these two base angles are also congruent to each other. And since the isosceles trapezoids are similar to each other, I have these angles also congruent. So to figure out y, I don't have a formula to figure out y. I don't need to set up a proportionality. I just need to use the fact that my angles are congruent and figure out that y is 110 degrees big. Since my angles are congruent, I don't need to set up a proportion. I just need to solve using what I know. Since the polygons are similar, I know that my sides are proportional. So I'm going to set up a proportion. X relates to 4, as 6 relates to z plus 2, as 10 relates to 8. Notice that my numerators are all from my polygon on the left, and my denominators are all from my polygon on the right, and I've made sure that the sides line up. Now to solve this proportion, I have 3 things that are equal to each other. I just need to pick 2 of them and solve for my variables. So if I'm going to solve for x, I'm going to pick the ratio that involves x, and then I'm going to pick this proportion, 10 over 8. And the reason I want to pick 10 over 8 is I just have 2 numbers. If I pick this ratio, then I have to deal with x and z, and that's just going to be more difficult. If I pick this ratio and this ratio, I can solve for just x by cross multiplying. 8x equals 40. Divide by 8. X equals 5. So I've solved for y. I've solved for x. Now I need to solve for z. To solve for z, I'm going to pick the ratio that involves z, and then I'm going to set it equal to the ratio that has 10 and 8 in it. I could pick this again and plug in 5 for x, but I'm just going to go back to this. Cross multiply. Cross multiply. Notice that z plus 2 gets put into parentheses. Even though it doesn't have parentheses here, this fraction bar is a grouping symbol. It's grouping my denominator together. It's saying this is one number. So when I multiply by 10, I need to make sure that I multiply everything by 10. Solve for z. I'm left with z equals 28 over 10. And 28 and 10 are both even numbers. They're both divisible by 2. So if I divide my numerator and my denominator by 2, I'm left with 14 fifths.